at the moment, I think the best guideline is, be ultra careful, talk to experts, maybe create an IRB before you get into any human subject experiment of any kind. Even if you don't think it's human subject, if you are deploying something that uses data in which there are humans, it is some experiment on human subject. So at the moment, we are at a very early stage where basically we have to tell people, don't do it, right? Start thinking about it, consult with experts and think hard, but we don't have really itemized recommendations to give you. But then I fear, the entire AutoML community is going to be frustrated. Maybe it's going to turn their back to the possibility even of thinking about fairness. So what could be, next steps that are a little bit a little bit more, positive than telling them, don't touch it, it's going to burn you.
I can throw sorry, Florian, go.
I'll just maybe add one sentence to that because I find it really important. And that is, it's not only that people are building AutoML systems, but it's also that sort of models are already deployed. This is all already happening. And if we keep telling people just don't do it, don't do fairness, then it's not a good answer for people who are sitting in a bank and deploying models that need to take fairness into account, or that want to take fairness into account. So I think that sort of problem needs a solution rather quickly.
So I wanted to talk a little bit about the evolution of this conversation on fairness, right? 10 years ago, it was very difficult to even have that conversation. Forget 10 years ago. When I was working on gender shades with my co-author, Joy, I didn't tell my advisor, I didn't tell my lab mates what I was working on because it was so difficult to even just explain to them what I was working on and why it was important. So that's where we were, right? But then, back in the 60s and the 70s, when standardized tests came up, there were a lot of people in education doing this kind of fairness work, different metrics. I mean, all this stuff like equalized aux, equal opportunity, all the stuff we're talking about, they were working on those kinds of things and looking at the issues, pros and cons, etc. And then it kind of fiddled off. So actually my collaborator, Meg Mitchell, has this paper analyzing why, what kind of learnings can we take from that thriving community of people who was working on this, and then it sort of just kind of died down, right? So in the sense that the kinds of things we're talking about right now are an evolution in the discussion about fairness. Because initially it was so difficult to even get people to talk about technical stuff, just, metrics or whatever, how you should think about it. It was impossible to even get people fair ML, FACT was not a conference. It was a workshop. A few people went, etc. So the next step in the evolution is to say, this technical stuff that we're talking about is not enough. We need to do this, more things, right? So that's kind of where we are in the conversation because we're seeing the limits of the technical things that we were working on. So maybe, Isabelle, what you're saying is, in AutoML, we need to get people to even start with the, with the, conversation, even where we were 5 years ago, 6 years ago. But the issue is that people need to look at all of those things together. So we do have some guidelines. So one of the things I would look at is, like I said, there is, frameworks you can look at. There's one that's called the AI accountability gap that, Deb and others, and I'm involved in that paper too. It's a framework. And there's model cards for model reporting on what kinds of things you should test on. There's data sheets. There's all sorts of guidelines. But one of the things I want to say is that what I have found is we need institutional changes. We need changes for our conferences, for example, to value certain things. So if we tell people, for example, spend 3 years on data gathering and annotation, not 2 months, and then they can't publish anything. Their graduate students are all frustrated. They can't get a job, whatever. we were not going to have any changes, right? So if we're going to tell people, think very, very carefully about data work, it's really important, it's undervalued, we need to reflect that in our reviewing practices and our best papers and our conference, practices. So my first takeaway would be that, right? So every single thing I've worked on personally, where I've had, for example, our latest paper at DARE, it's on spatial apartheid. It's on analyzing the evolution of spatial apartheid in South Africa using computer vision techniques, which means both the techniques and the data sets are developed for this specific task. We're not saying we had a general universal segmentation model. We're not saying we have a general universal data set. We're saying we developed this thing for this specific task. It took us literally 5 years to work on, or 4 years to work on this project. And let me tell you, trying to publish it, it was finally, the NeurIPS data sets and benchmarks track for me is a great change. It's a great addition, right? So because trying to publish this work was ridiculous, right? So I definitely don't care right now, but I was working with a more junior person for whom it's extremely demoralizing if I'm telling her to spend 3 years, 4 years doing this thing that's so much work, and she can't even get it published. At CVPR, they'll say, but who cares about this? Is it generalizable, blah, blah, blah. At some other place, they'll say, but what about the algorithmic component and stuff? So to me, that's the biggest kind of take-home message that I'm hoping to work on, is how to get our institutions to value the kinds of practices that we're talking about. If I say you should have model cards for every model, data sheets for every data, and you should spend more time doing disaggregated testing, etc. I'm saying that for each output that you have, you should spend more time and more money for less, projects and papers, right? Instead of spending 2 months on something, you should spend 2 years. And if I'm saying that, and it's not supported by any of the institutions and practices that we're in, it's going to be very difficult for people to do any of that. So for me, that's kind of what I would recommend. And so the conferences can help. So for instance, the data sets and benchmarks tracks now says, every data set should have a data sheet or data statement or equivalent. That's great. So all of us need to do that now. And then somebody can say every model can have, something or an equivalent. So once we have those kinds of guidelines and standards, everybody's sort of like more incentivized to follow them rather than, it's just your goodwill. For banks, there's regulation. So it's not just their goodwill that we're depending on. They have to abide by certain rules, right? So it's these sectors that are regulated. Everybody has to put in the resources to do more. So to me, I believe much more in institutional changes and regulation in those kinds of things that level the playing field for everybody, rather than, you tell some junior person, you got to do this, and then they lose out because they're completely demoralized because they can't publish anywhere, they can't get hired anywhere, etc.
Right. We have a couple of people in the room with questions, and they've been lining up here. So I pass the word.
Thank you. So I think that even if I hear everything you say and I can see how important it is, it seems to me that that's weird. It seems to me that whatever metric of fairness we can introduce, even if we try to optimize it as best as we can, if we don't get it perfectly, if it's just one person, like this 0.001 error that we're making, and if it's just one person that gets their life ruined because of this is already a fail. And then it seems intractable. It seems like a problem that cannot even be solved somehow. And we can do whatever we want and do everything to make it well. I feel like it's not solvable. And that's a bit, I don't know if you have anything to raise my spirits about that.
I'm sure I can add, but I'm sure my co-panelists also have things to say. So I'll let other people chime in. Or I'll go ahead and then if you, okay. So I think that what you just said it's kind of how we're trained as computer scientists, as engineers. We are trained that there is this problem, there is this optimization, there is this optimal solution, right? But life is not like that. And the world is not like that. When you look at all of these other professions, like doctors are not like, hey, look at medicine, right? Our clinical trials had, this kind of success, etc. Here are some of the side effects. They write it down. X% of people could be impacted by the side effects. Y% of people might have this, etc. It's not like if 100% of people are not cured with 0 side effects, then we throw out the medication, right? That's not how life is. So how do we deal with these things? Looking at clinical trials. We say, okay, here's the first thing. Before we put out any medicine out there, it has to go through this test, that test, these standards. Number one, we have a body called the FDA in the US, right? That checks whether the standards were met, whether the clinical trials of this, of that were done, and what the results were, how the results have to be disaggregated. So for example, I mentioned a little bit on clinical trials earlier in my talk, and it was in the past, they didn't even have to tell us the different characteristics, women, different ethnicities, different races, different ages, etc. They didn't have to tell us how their medicine that they're testing impacted those different groups of people. Right. So the fact that they had to disaggregate the results by those groups of people and have more inclusive groups in those tests was regulated. Right. So now they have to do these disaggregated testing. In machine learning, we have suggested disaggregated testing just to see what kind of impact you have on different groups of people. Then once you even put out the medicine, you don't put out the medicine and you're done. You write out what the impact is, what the potential side effects are, etc. Depending on what you have. Don't drink alcohol, with this medicine. Don't do this other thing. And even then, it might be something that's unknown. We have made analogous suggestions to that, right? So there's people who suggesting nutritional label, data nutritional labels, they call them. I call it a data sheet for my paper, or model cards for model reporting. It's kind of an analogous thing. Then you don't just take the medication and you're done. You have a doctor that you can go to who can monitor your tests and things like that, right? So that's what I'm saying. There's this complex ecosystem of things that are going on, and complex bodies, groups of people that are doing tests, monitoring things, etc. If you just abstract out and think of your job as to optimize some metric and get the optimal value, you're correct. You're absolutely correct. And in fact, that is the message that I've been trying to drill in, is that there is no single metric that's going to solve everything with your equation, right? The whole point, though, is that, and for you, I think a great paper is Fairness and Abstraction in Socio-Technical Systems, that says that literally kind of that mindset, that thinking that one metric that we optimize for something, abstracting out everything else, can solve things, can actually be harmful if you thought that was possible, that you could just solve the problem by optimizing some equation. So in summary, I think your comment is correct. You can't optimize fairness away and solve it and call it a day. This is not a tractable mathematical equation, problem where we can prove bounds and say, you do this, you've proven it, you're done. But each of us can, there's a huge ecosystem of people and things that need to be done. And each of us can take a piece of it while having a wider view of who we need to collaborate with for making things better. Do you feel a little bit better? I kind of want to know if you feel better or worse after that. Okay.
Okay, good. Thanks so much for the discussion. This is Wei Wenjiang from George Mason University, and I'm very happy to see we bring the topic of fairness into the AutoML. Actually, recently we also do a lot of work on such kind of topic, and we identified that the neural network model indeed affects the fairness a lot. I am not maybe a question, but I have some comments when we do such kind of things. As also what we have already discussed, actually, when we do such kind of, when we consider the fairness in the AI, in the machine learning model, in the AI domain, actually we are more specific on a specific task. Do you think that we can separate the fairness out from the system, or do you think that it make more sense that we need to consider not only the fairness, the accuracy, but we also need to consider the constraint of the system, like when we, for example, for the medical application, at the end of the day, actually we need to put the stuff onto the device for the running, for the execution. So do you think it makes more sense that we need to consider the full system design instead of just separate out the fairness and the accuracy stuff? So I think this is some of my thoughts on the fairness in the AI system in the AutoML, and also I want to hear your idea, your thought about such kind of problem.
My co-panelists are too shy. I think you all have stuff to say, so I'm going to shut up and let you guys talk.
I guess I'll say some things to fill the space. So, I mean, yeah, I think that there's already kind of two ways that people do fairness. Like one is trying to do it up front and optimize the models based on fairness metrics. So that's sort of integrated into the model training system or the process there. And then there's like the other side where you just have the models and you just afterwards try to evaluate the fairness or bias or things like that. So I'm not sure if that's exactly what the question is like, can we keep this kind of separate as like a, third-party system, or does it have to be fully integrated? And I don't really know the answer to that, but I would say like the more that you can do upfront to just try to build fair models to begin with, like the more likely you are to succeed at that. I don't know if that's very deep, but I think, I can
add a little bit to that. So let's say you build something. Okay, so answering the prior question, I was like, that is a very computer science kind of training that we've been trained, or mathematical training where you need to optimize something, et cetera, right? But actually I'm wrong, because I used to be an electrical engineer and I used to be a circuit designer. And my inspiration for the paper I wrote called Data Sheets for Data Sets was actually electronics. It wasn't anything else except for electronics. And in electronics, we have, I would say that the components that we have are analogous to models sometimes. So let's say we have a resistor, right? Or something that a resistor can be in a power grid. It can be in a life support system. It can be in your computer. It can be in a little toy. But the idealized version of a resistor, if I teach you what a resistor is on a class, EE 101 or whatever, on the blackboard, I would write out an equation, V equals IR, like voltage equals, current times resistance, right? That is the idealist version of all resistors, all models. In practice, you can't have the same material, the same resistor that you use in your life support system versus the power grid versus a toy for a 5-year-old versus your laptop, because they require very different characteristics. A life support system, that means somebody's life is on the line. So you need to have robustness, right? If it's for audio, it means that your resistance signal needs to be super clean, because like the audio that you're listening to can pick up any sort of noise from the resistance. If it's a power, what you need to do is handle lot more voltage. So even if the idealized version of the resistor is the same for everything, depending on the application, it needs to have very different characteristics. And there are different standardization bodies. There are different there are different certifications that says this resistor is certified for this use, right? This resistor. So the reason I'm giving this example is because if you look at any sort of machine learning model, even if the idealized version is the same, like it's an object detection model or whatever, it's meant to detect all objects, depending on whether you're using it to detect someone's disease and decide whether this person has, terminal cancer or not, versus it's like in some sort of toy thing, you're going to require lots of different metrics, right? Your evaluation is going to say whether it works or not is very different for those things, right? So even if you have specific metrics, let's just simply like false positives, right? Whether what you need to maximize or minimize is going to be very, very dependent on the specific use case, right? So so in my view, you have to really know the use case, right? You can't just, in order to really see. And so there is a tutorial called 21 Definitions of Fairness and Their Politics. That might be interesting for people because we don't have any shortage of definitions of fairness. So, oh yes, hey Frank, sorry, I didn't.
So, I mean, you mentioned you would like more regulation, and that makes a lot of sense. And you're saying there are a lot of fairness definitions. So those are definitions, and well, those are mathematical formulas. It's just a question which one is the right one for a particular problem. That needs to be decided by domain experts, SSS, not by the machine learning engineer, the poor machine learning engineer who is tasked to solve this problem. And well, if there's a regulation, then well, we have an objective function and we could optimize for it and for accuracy, couldn't we? Because the alternative is that the poor machine learning engineer who doesn't even know anything about fairness does something, and that's not helping the world either, right?
So are you suggesting that the law should determine which fairness metrics are being used, or what's the suggestion? Because like I
thought that was Timnit's suggestion.
Oh, okay, sorry, I didn't really...
Oh, I mean, the law does determine that in some ways, and actually, a lot of these definitions are taken from U.S. Civil rights law. But I also think that when I was talking about the EE case, use cases, it's not always the law. Like and I actually want to study how these standardization bodies came to be, because everybody follows them, but it's not necessarily the law. And if you're an engineer, you would build a specific type of resistor for a specific thing. You'd have the specifications, you'd know, but you would be the one who builds that, that model. You wouldn't leave it to like some other person to re-engineer it or something like that. But I do agree that regulation is an important kind of like part of this, right? I do agree with that.
And in a sense, and if you have regulatory statements, they need to be well-defined and procedurally or mathematically, and then we can take those as objective functions and put on top the objective functions that people would have in companies, such as, well, accuracy or quality of service or also monetary rewards, and well, be within the bounds or even better than required by the regulation, while at the same time also being good in the other objectives. So I think that's really something where very customized AutoML systems are not one model to serve it all and generalize to everything, but really customized on a per case basis. I do see a possible future there, and I'm like many here. I'm looking for some positive end to the panel and not go home frustrated and say, well, what we do is sort of not really incompatible.
Then I think I'm going to leave. I was going to give an example from banking that was not as positive, so maybe I should leave it to myself. But maybe okay, so I'm just going to tell. Anyway, so I've worked a bit on fraud detection models for banks. And one of the things that you really see, at least in the Dutch scenario, so I don't really know how it works in other countries. But basically, there's this big, the big overarching organization called the Nederlandse Bank. And then they pretty much decide when your fraud detection is good enough or not. But then basically what happens is they do not actually give you specifics on what that looks like. Basically what they do is they just tell the banks, you go try, and we say whether it's good enough or not good enough. So in that sense, at least in situations like that, even though there is some regulation that basically just gives authority to the Nederlandse Bank to, organize all these kinds of things, it doesn't actually give you specifics on how to actually solve, or not solve, but how to actually define those objectives based on the laws that are there. But that's just, I don't want to give more negative examples. So.
Yeah, and I think I would also add that as we are talking about fairness, I think it's also, and regulations, but along this, we should also think about explainability and causality, because those are also, I think, important research items to look at in conjunction with fairness, because in AutoML, we are trying to automate, but we should also really understand what is it that the model has learned from the optimization, because I think whether it's using the right feature to make the decision, or whether it's just learning some spurious correlation and taking biased decisions. So that's also, I think, something that's definitely important. So I think, there was a discussion on guidelines. I think we should definitely try to adopt this a more, not necessarily axiomatic, but we should definitely try to understand the use case and what are the requirements for that use case in conjunction with domain experts. And then I think those considerations need to be taken into account before we start out to put in these optimization objectives. And of course, a perspective of explainability and causality is also definitely helpful.
All right, with that, I'd like to maybe just give everyone a possibility to have a final statement, and then maybe I'd like to, given the time, also allow you to get back to your other duties. And it's also getting late here. We need to finish the conference. So final statements. You don't have to, but if you'd like to say anything, maybe with a positive twist, that'd be awesome. Thank you.
I think that we can look to other fields. Like I said, Omayama, I don't know if I'm saying your name correct. we're having a chat conversation here. We both come from an electronics background, and, our education is about, risk, metrics, feedback loops, all sorts of stuff. So, don't feel so overwhelmed. Like, there are other fields that we can look to. Our training is what kind of is lacking, this assumption that there is a universal model for everything that we can automate and optimize. I think that's the notion we should move away from. We can carefully select our data sets. We can think about our values. We can work with domain experts. So you can look at data sheets, model cards, all sorts of other kind of guidelines. Erin has been great in collating all the papers that we've been talking about here. So there's a lot that can be done. And our institutions can also help us institute guidelines so that, they reward people who do this kind of work.
Yeah, I think my message would also be we need to definitely understand that.
I'm looking forward to this interaction between the AutoML community and the fairness community growing. And let's see where we are in 5 years. And maybe then we have a clearer picture of what we can do. Thank you very much, everyone.
Thank you. Bye, everybody. Don't be depressed.
Thanks to all the panelists. Bye-bye.